Okay, it's good day, class. Can you guys hear?
Yes, sir.
Can you see the screen?
No, sir.
Okay, yeah, you should see it now. This takes a bit to load. Guys, start seeing it?
Yes.
Great. So I'm recording this class. I kind of forgot to record, I think, like the last two classes, but I'll record this one and upload it with the others, right? All right. So another class, another circuit, another different sensor, different device that we're going to use to communicate with our microcontroller. How are you guys coming along with the assignment, the essay, and the just the LED project? Come along well?
Yes, sir.
All right. Should be easy. All right. And remember, you have any problems with your assignment, just message me and I'll try to help you resolve the problem. Okay. So today, we're going to talk about the light dependent resistor, which is a slightly different kind of sensor. All right. So let's review from last week. So we had this temperature sensor, right? The TMP36. And we had a data sheet for it. And we looked at how it works. And essentially there were three terminals, right? The power, the positive, right? The ground, essentially, or negative, and a V out, which is the output signal that we would send into our Arduino, right? So we essentially had to power this sensor, and then the sensor would generate some signal to send into our Arduino. Now, not all sensors are like that. For example, there's a thermistor, which is similarly a temperature sensor, and this is how they usually look, right? It's a temperature sensor, but you notice that it only has two leads. Its name is the thermistor and has just short for thermal resistor. It's essentially just a resistor whose value is very sensitive to temperature. So as temperature increases or decreases, the resistance changes. So it's a sensor that acts in the form of a resistor, right? And we know we can build voltage divider circuits or Wheatstone-Bridge circuits to help communicate that change in voltage based on the change in resistor to our Arduino. So for something like this sensor, a light dependent resistor, or what is also known as, let me get my pen so I can write it. Okay. Or what is also known as a photoresistor is essentially just a resistor whose value, right, whose value changes with light, right? Changes with light. And we know we can use some sort of voltage divider circuit or maybe some kind of bridge circuit, right? Which you guys were exposed to in your other electrical classes. Okay. Good. Now, in order for this to work, we're going to have to set up a voltage divider circuit with this light dependent resistor, right? So how we're going to do that is we're going to set the resistor up pretty much the same way we would do with a switch. So we would have like a switch here. And we'd have this pull down resistor. And then of course that'd be going into some digital output. But instead of going into digital output, we're going to send it into one of the analog inputs. So instead of going to a digital input, we'll send it into one of the analog inputs. So any of the A0 to A5 pins, right? It's going to go in here. We're going to have that pull down resistor connected to ground here. that's going to have some value that allows us to modulate this 5 volts in a way that we can generate some kind of signal, right? Because we want this 5 volts varying from 0 to 5 volts based on the change in this resistance, right? And we're going to connect that resistor up on the other side to the 5 volts, right? Essentially, this is just going to be a resistor that changes, right? And then this is, of course, connected back into that A0 pin there, right? So the analog pin is connected in between those two resistors. The simple voltage divider circuit for that is just something like this, right? You'd have your 5 volt supply here, right? Where is that? Something like this. So plus 5 volts, your battery, circuit, 1 resistor, right? 2 resistor, coming back around, right? So this here is your plus and minus 5 volts, your grounds and your 5 volts, right? Here in this battery here. And then some current is flowing here. And the signal is V out here, right? Some V out. And this is, of course, based on these two resistances, right? Simple voltage divider circuit. So this V out, we know V is equal to I times R. So therefore, V out is equal to I times, let's call this R2. Let's call this R1. I times R2. I, on the other hand, V is equal to IR. I is equal to V upon R. So the current in here, right, is a function of the resistance and voltage coming from this 5 volts, right? So that's going to be I. We're going to replace I with V upon R, and that V is this V in, right? The voltage across here, because the current flowing there is a function of that, right? So V upon R, right? So this current in this line, let's call it I1, is the same as the current in this line, right? I2, because there is no load here. This is just a reference voltage, right? There is no load here. So if I1 is equal to I2, then the resistance based on this voltage here, this V in, let's call that V in, right, is going to be R1 plus R2 plus R2. And then, of course, that's just I, which is I times R2, right? So that's just R2. So we end up with some equation. Let me write it back a bit neater. Actually, they have it right here. V out is equal to V in times the resistor, which we call R2, divided by R1 plus R2, right? The basic voltage divider equation that you guys are accustomed to and know. Right? Okay. Now, we also need to find a value for this resistor. Right? How do you do that? Well, for this particular resistor that they're looking at in the textbook, they combine it with a 4.7 kilo ohm resistor to form the voltage divider because they know that in average daylight, the resistance is about 3 kilo ohms to 5 kilo ohms. So they know 4.5 kilo ohms is a good range to put their resistor. Now, alternatively, in Tinkercad, when you drop in your photoresistor, you can use your multimeter to measure the resistance and vary the amount of light coming in with the slider because it's a simulation, right? In real life, you would take the resistor, you'd hook up your multimeter, right, to measure the resistance, and then you would put your hands around it or maybe some black tape to reduce the amount of light the sensor sees, and then take that tape back off or remove your hand or shine a light on it to increase the amount of light the sensor sees so that you can see how much the resistor varies. And also, these resistors would come with a data sheet as well, which you can look at, which we looked at last week. So you can look at the data sheet and pick out values and see what a good resistance would be to create your voltage divider circuit, right? Okay, and we'll look at that when we start doing the simulation, right? Okay. So they know with average daylight, it's about 3 to 5 kilo ohms. So they chose a voltage divider resistance of 4.7 kilo ohms, which seems good. Okay. Okay. Now, how we set up a circuit, I explained that before. Let's look at it in Tinkercad, right? From 5 volts to one end of the photoresistor, right? Next end into the analog input, we use A5 here, right? Pull down resistor here, ground, right? Ground, connecting to ground. And you have some light to show how the photoresistor varies because we just want to explain its operation, right? So use some light to perform some simple logic. Okay. Now onto the code. Okay. Okay. So first, set up some variables because remember, we don't want to hard code this because we don't want to have to go through each line of the code and change V divot, V divot, V divot all the time or the LED pin through each line of the code. We don't have to change it. If we're ever in a situation where we have maybe 100 or so lines of code, right? So it's good to build the habit now. So int V divot is just the pin where we're putting the voltage divider circuit. That's the pin where the voltage signal is going to go into, right? Because that's the analog input pin. A0 is good. Then there's int LED pin 11. That's the pin where the LED is connected to, right? The LED is connected to 11. In our circuit, we did A5 instead of A0. Okay, so we need to keep that in mind, right? 11. Now, because they want to do some PWM stuff down here, they chose a PWM pin, right? Now they have some value here that's called thresh, which is some threshold value, which we'll talk about a bit later. Let's just get the basics of the program down. And then there's some value for reading, which we'll use as a variable to store a reading when we do our analog read function to read the value that's coming in from VS, right? Some value is going to come in from VS. So you're going to want to read that value. And since we're doing some PWM-based logic with the LED, maybe making it brighter or dimmer based on the amount of light that's coming in, we're going to want to use some variable for that bright. So what is this circuit? What does this program and circuit do? Well, this program and circuit adjusts the brightness of an LED based on how much light there is, right? So if the place is very dark, the light is going to shine brighter, right? The LED is going to shine brighter when place is dark, right? When dark. When it's bright, like during the day, it's going to turn off. Right? When it's too bright, they want to turn off or dim. Right? So that's the simple logic and the purpose of the circuit. How we go about doing that? Again, as we usually do, right? We set up our LED pin as an output, right? Basics, right? If you want to do serial commands in there to troubleshoot your program along the way, you want to print different values to see whether or not it's working. You can do serial begin and use your 9600 baud rate, right? So that you can troubleshoot along the way and see what values are being stored, okay, throughout the program. Now the loop, which is the main part of the program, the part is going to be being repeats all the time. Comes in, reading, equal analog read, V divot, which is just the pin, right? VS pin, Could rename it to that if that makes more sense than VDivid. VDivid is just short for voltage divider. Analog read that value, and we're setting bright is equal to 0, right? Just initiating the variable, right? You can alternatively do this in setup or do this even before, right? Because that value is going to change. But there's also some logic here that requires it to be reset to 0. So if you're changing it, just be aware of that. Okay. Okay, good. So now there's an if statement. They're saying if the reading is greater than some threshold value. So if you read here, remember analog read, the signal is from 0 to 5 volts. And based on that, they're going to produce an output of 0 to 1023. If that reading is somehow greater than some threshold value, then do something, change the brightness. So essentially what they're saying, there's some cutoff point, right? They're saying if it's greater than that, then turn the light on at some particular intensity, right? So it's like saying that, okay, if it's kind of bright during the day, leave the light off, right? Then in the afternoon, leave light off still. But in the late afternoon, when it's still bright, but it's not that bright. So maybe like 5 o'clock, when it's kind of start getting darker, when it's passing that threshold value, then start turning the light on. And then as we can see where the program is going, increase the value, increase the PWM value that we're sending to that light as it gets darker, right? So darker from the light sensor, brighter, right? Make the light brighter. Basic logic. So how do we do this? Right? Good. So now, if reading is less than the threshold value, right? That reading is going to be based on 0 to 5 volts. And we look at how the voltage changes in the circuit with the multimeter a bit later. Then we're going to do some mapping, and that maps the PWM value, right, that we want to put on. And then we're going to write that value into the LED pin. Don't worry, I'll explain what this command does and what it means later. And then we're going to delay a little bit because we don't want to be constantly changing the value or cause the light to be blinking too much, right? Like, let's say there's some sort of fluctuation in the reading. We don't want the value to be changing that fast. We want to give some delay in between, right? If that delay is too much, you can reduce it. If it's too little, you can increase it, right? But we don't want the light to be shining bright and then dim and then bright and then dim, causing it to appear to flicker, right? We don't want that kind of stuff happening. So we delay a little bit so that it slowly dims and increases its intensity. Okay, so we have the circuit set up. We have the code, copied it. I made some changes. All I changed it was A5. From A0 to A5, I use the same LED pin as PW. I changed the threshold value to 800. I'll tell you why I did that. Okay, but everything else is pretty much the same. Okay, everything else is pretty much the same. And of course, I adjusted the resistor value for my own reasons. It's 5. Okay, good. So photoresistor, resistor. Let's look at the photoresistor that's built into Arduino. Right, photoresistor. This one here, and let's pull up a multimeter. Okay. Check it. And let's put it resistance. Well, I think you need to start the simulation before you can change that, but connect it up to this. Start simulation. Against no voltage because not connected to anything, and you put the resistance, right? Then because it's simulation, we use a slider to see how the resistance changes, right? In real life, you would just put your hands around it or put some black tape around it, right? Put it underneath your desk, someplace dark, right? Shine some light on it to essentially figure out this change. And alternatively, there's always the data sheet that you can look at. So you look at it and we see the resistance values are 180 kilo ohms, really low, right? Can increase a little bit and it starts jumping to about 13 kilo ohms. So it's not exactly linear at this part, right? And around here, which is just average, is about 1 kilo ohm. And really bright, it's lowest resistance ever, right? So the brighter it is, the lower the resistance. Good. Now we can remove this. Stop simulation. And we can look at the voltage based on this voltage divider, right? I need the ground. You can start the simulation. And it's set with resistance, so we can change that, right? To millivolts, so some millivolts. And then we click on the resistance. Slide this down again. Click on the resistor, photoresistor, and we change the value. We see it here, it's 5 volts. It's well close enough to 5 volts. And there it's just a few millivolts. So that's close enough to 0 and 5 volts. So what we can do from here is adjust the resistance and see if that makes a difference. Now, if we go lower, let's say 2 ohms, we see that it can go down to 55 millivolts. But when it comes up, it only comes up to 3 volts as opposed to our 5 volts from before. Right? And then we can stop again. We can adjust the resistor to something like 20 kilo ohms. Start simulation. We see that the lower end of the voltage doesn't go as low as 55 millivolts, but it does come all the way up to 4.88 volts. So we see that there's a change in resistance, changing on voltage based on how we change this pull-down resistor. So we can average a good value. My average would just be 5 kilo ohms, right? 5 kilo ohms, which is pretty close to what they have as well. Right. Now, alternatively, you can do this with your math. Use the equation. Figure out what the voltages would be, what the voltage range would be, because there will always be a voltage drop across this resistor, right? There will always be a voltage drop across this resistor. So it's not going to be perfectly 0 or perfectly 5 volts, right? Okay, good. All right, so with that in mind, let's talk about this mapping thing, this part here. So this thing here, this function, map, right? If you don't know what a function is, you can always just type map function Arduino, and you can just go to the Arduino website, and they have references for all the functions, right? Usually the book would explain that function a little bit, but if it doesn't do a good job, then you have this alternative resource, the Arduino website, and you can look at the function and it goes through examples and descriptions of how to use the function. All right, but I'll explain it to you. So this map function, map, and it takes quite a few parameters, right? So this here we know is a function similar to some things like analog, right? we know it takes the inputs and it does something to them, whether it's send a high value or set it as an output or anything like that, right? We know a function, it takes something, it takes the input and it uses that to do something, right? So that's what map is. Map is a function. Now here we see if reading is less than threshold, and we know what we want to do with that. We want to turn the light on when it passes that kind of threshold, right? But we use this function to set the value of bright, and then write that value to the LED pin, which is based on a PWM value, right? So we also need to know is PWM value. So few things. The signal that's coming in 0 to 5 volts. The 0 to 5 volts gives us a value of some 0 to 1023. However, not fully 0, not fully 1023, because it's a voltage divider circuit, so it's a few millivolts and a few millivolts less than 5 volts. So it's close enough, right? About like 30 to, let's say 900, right? Somewhere around there is our range. Let's use the ideal situation. And then we know PWM values are from 0 to 255, right? 255, 0 to 255. So if it's off, it's 0. If it's at full brightness at 100% duty cycle, it's a 255. So we want to map these values, right, to different values of the PWM signal. We can map it evenly by saying, okay, we can map it evenly by saying here, okay, 0 to 0, 0, 10, 23, maps to 0, 255. And what this does is essentially mapping all the different values in here to all the different values over here. Let me explain that a little better. Let's say in here we put it 0 to 50, and here we put 0 to 50, right? 0 to 50. What this would do is it would map the number 0 to 0. It would map the number 1 to 1, 2 to 2, and 50 to 50, right? 3 to 3, 3 to 4 to 4, 5 to 5. Kind of like a direct relation. If we did something like 1 to I'm gonna change the size of this thing. Okay, great. Okay, so 0 to 100 instead, right? How would it map that? Well, obviously it'll map 0 to 0, and it'll map 50 to 100. But the numbers in between, let's say 1 is gonna map 1 to 2, right? And it's gonna map 2 to 4, and a number like 5 to 10, right? So you can see the logic between mapping these different ranges. So because we're constantly converting from analog read values to analog write values, remember analog write 0 to 255 and analog read 0 to 1023, sometimes you want a linear map in between, right? We want to map some numbers here to some numbers here. We want when 255 is there, we want 255 to be 1023, right? We want 0 to be 0, and you want everything in between to correspond to different values within that range, okay? So when we do this mapping here with a function like this, we're ensuring that Now we can input a value, say 5 here, and it's going to say, okay, 5. What is 5 in this range? 5 is 0, 1, 2, 3, 4, 5. How does 5 map to this range? And then it maps it over. Similarly with our 0 to 50 and our 0 to 100. And let's say we had some input value of 2, right? It would say, okay, 2 in this range is 2, but 2 in this range is going to be mapped. Right? 0 is mapped to 0, 50 is mapped to 50, 1 is mapped to 2, 2 would be mapped to 4, and it's going to put that value, it's going to output that value out. So if we say x is equal to map, it's going to output the value 4 for this case, right? For this case, it's going to output that value 4 out into x. In this case, 5 is going to map 5 to some value between 0 and 255, right? Some value in between there, and it's going to output that into x here, right? So essentially, that's what we're doing. But remember, we want, when it's bright, to turn the LED off, and when it's dark, to turn the LED on. So we notice when it's bright, it's 5 volts, and when it's dark, it's closer to 0 volts, right? A little bit of millivolts in between, right? So when it's bright, it's 1023. So we don't want 1023 to be mapped to 255, right? We want 0 to be mapped to 255. So what we do is we turn this around. So we do 0 to 1023, 255 to 0, right? So that we map it in reverse, right? So when it's 0, when it's darkest, is going to be brightest. When it's 0, it's going to be 255. When it's darkest, it's going to be brightest. And when it's brightest, it's going to be dimmest. It's going to be off, right? Now, within that, we also have a threshold value. So what we can do is say, okay, don't wait until 0 to turn it to 255, or don't wait until 1023 to turn it off. Maybe when it's just a few volts, like 4 volts or 3.5 volts, right? Then we can go ahead and turn it off because it's already sufficiently bright, right? Or don't wait when it's completely dark, full darkness, wait until it's just a few millivolts, something like 0.5 volts, right? Right, something like 0.5 volts, then to turn it off. So we can change these values in here to something like 30, comma, and not all the way up, but their threshold value, something like 500. And this would map to that full range. So anything higher than this, it would just turn off. Anything lower than this, it would just be 255. Okay, so that's using this knowledge. Let's look back at what they did in the program. So what they did, they said if reading is greater than threshold, right? If the voltage coming in is more than, let's say, 4 volts, right? If it's less than that, less than 4 volts, means the place is starting to get dark, right? Less than sign. If it's less than that, means the place is starting to get dark. Okay, so then we're gonna start mapping bright. So that threshold value defines how dark we need it to be to turn the lights on. Otherwise, that light value is going to be set to 0, right? So that's what that threshold value does. Now we're mapping the bright value, which is the value that we're going to store PWM value, some value from 0 to 255. If it's not already 0, we're going to store some value there. We're going to store some value there based on how bright the place is. So we collect that reading in, right? I remember that reading is going to be some value from 0 to threshold. So threshold here is 500, right? Remember we talked about it mapping from 0 to 1023. And then we talk about how we can set some offsets, reduce the value that it's mapping, because we don't want to map the entire range. We just want to map a piece in between, right? We don't want to wait until complete darkness to make it the brightest, nor we don't want to wait until maximum brightness to turn the light off, right? So we can use these threshold values. Of course, we can introduce another threshold value because we noticed our voltage in our simulation doesn't go to 0 volts, right? So we're never gonna get that 0 value in. So, but we do want our LED to shine at maximum brightness at some point. So we can input some value there like 30, right? And you can use your serial print command to communicate serially with your analog inputs and print the different reading values so that you can see, okay, when I put it at this amount of darkness, what's the value coming in? Okay, what's the serial value coming in, and assign your threshold values as you see fit. Okay, good. So it's gonna map that. It's gonna find some value between 255 and 0 based on how dark the place is. And then it's gonna write that analog rate. This is how we write PWM values to the LED pin. So the LED is at some kind of brightness, some desired brightness based on the reading, and you make adjustments as you see fit and necessary to make sure your system works the way it's supposed to. And then you just delay 1,000 so that you're not getting that flickering effect which you're dimming, right? Okay. So these values in here, not this and this, but this can be altered to make your program function more smoothly, right? So this is the program. Do you guys have any questions? Any particular line that doesn't make sense? Yes? No? Are you guys following?
No, sir.
Yeah, good. So you're not following, or you are following?
Following, sir. No questions.
All right, good. So you guys can build this, right? And now I made a few changes, right? But don't go ahead and make the changes I did right away. Experiment for yourself and see how the program functions, and then make changes on your own, right? Use your multimeter to play around with the voltage divider circuit and see how the voltage varies, right? Put your serial begin command in here in the code, serial begin. Right? And you do your 9600 baud rate, right? And then in here, for different values of reading, you can print the value of reading, right? You can do serial print. And then you print reading. Start simulation. So that when your circuit's working, right, you see the value coming in, right? You see the serial value coming in, that reading value that moves from 0 to 1023, right? Printing reading. Well, that value that's supposed to move from 0 to 1023. But remember, the voltages are never 0 or they're never 5, right? So you can play around with that and adjust your values to make your circuit function smoother. All right, good. So you guys know how classes work. Explain a circuit and you guys build it yourself. Have any problems, go ahead and share your screen or ask me and I can see how I can help you to make your circuit work. All right, so take your time and start building the circuit. All right, and use the multimeter, play around with the photoresistor so you get an idea of how they function. All right, good. And if you want, you can open up the textbook, copy the code in, edit as you see fit, right? Change different things you need, or you can type it back, right? But be careful what you're copying and pasting in. Don't copy like parts like this on top, or don't copy the paragraph at the bottom and try and paste it into code, right? Okay, good. So, and this is the circuit simple, voltage divider setup, LED blink, pin setup, same thing, right? This is the code. Well, this is my code. Okay. Okay, so I see some questions in the chat. So, okay. Can your code have more than one void loop? So, Jarvis is right. Like, why would it need to have more than one void loop? Let me explain what void loop is. Okay, so Syad. Yeah. Okay, so there's void setup, and then there's void loop. Now, the Arduino programming language is based on C, right? Based on the C programming language, right? The C programming language. And in the C programming language, void loop and void setup are what's known as functions, right? Functions. But in the Arduino programming language, there's special types of functions, right? So void loop is a function that is automatically run over and over and over. Void setup is a function that is only run once. So if you need two void loops, what you can do is do void loop, and within it, put a loop, some for loop, put some for loop, which you guys know what to do, and then put another for loop, right? Which you guys know what to do. If you need to do two things, right? You need to do one thing, then another thing, then you just put both of them in the void loop, right? Void loop is a special type of function for the Arduino programming language that when you load it onto the Arduino board is going to execute repeatedly, right? It's the direct alternative to int main, right? In traditional C programs. So if you ever did C programming, there's going to have things like int main, which is just your main function, which when you compile it, this is essentially what they're going to execute, right? This is your main function. This is what they're going to execute. So void loop is just what they're going to execute, right? Repeatedly over and over and over and over and over, right? Okay. So if you just want more loops, then just use for loops, right? Use number for loops. Okay? And if you wanted to execute indefinitely, then the question arises, why would you want two loops, right? Because this here is going to execute indefinitely, and your second loop would never execute, because it's waiting for this one to finish, right? Because code is stepwise. It's going to go from 1 to 2 to 3, right? Line 1 to 2 to 3, unless we tell it go back up. So if we're stuck in this loop going on and on forever, right? We're never going to move on to this other loop. So for most of your purposes, you're just going to use one for loop and then another for loop. Or if you want things like nested loops, which is a completely other thing, right? Nested loops. Let me get a new. What is this? Okay. So there's also nested loops where you can put a for loop, right? A for loop. And then within that for loop, you can put another for loop. So this is also a thing that will meet your needs. There are also user-defined functions, right? user-defined functions, which is just a function you can define on your own by yourself. And I think I covered it in the first class. Let me just check. No, that's not. Okay, but user-defined functions are essentially functions that you can call later on in your program. So you can do something like create another function, something like you can say void, you can say something like void my function or calculations or area function, whatever you want to call it, my function. And it takes some kind of inputs or it doesn't take anything. And then you can write what that does, right? You can write what that does. And inside your void loop, right? Inside your void loop, you can refer to that function by just typing my function, right? Semicolon, right? You can refer to that, which should be the same how you would go about doing subroutines and functions in MATLAB. If you guys learned that, did you guys learn about functions in MATLAB? No, no functions in MATLAB. You learned about functions, right? So the same way the C programming language has functions, right? You can go to that same site I told you guys about, or whatever your preferred site is, right? But just the C version of it. I sent you guys this link, right? This site. You'll see, look at all the tutorials, and somewhere in here that it should have C functions. And you can look at programming functions, user-defined functions, and you can see how they created functions in C and apply that knowledge to Arduino, right? So you see here, they have some function, int add numbers, right? This is a function and not an integer, right? So usually we put void add numbers instead of int add numbers, right? But int says that it's going to return some value. So in MATLAB, you would have something like this. It would be function x1 is equal to area x area length and width, right? And then here would be some code to calculate length and width, right? And say x1 is equal to length times width, right? And when you call your function, in the main program, right? Because this is going to be some extra .m file in MATLAB, right? Some extra .m file. You're going to call it in MATLAB. You're going to say my variable, some variable is equal to, right? Some area function. And then you're going to put in your length, right? And your width. And then it's going to take those inputs. It's going to go to this script, this M file. It's going to calculate that. Then it's going to output this value into your variable, right? You guys should remember that from MATLAB. So it's the same way in C, right? You can create other functions, or you can just use loops to accomplish whatever it is you're going to accomplish, right? So if you want, you can just tell me why you need more than one for loops, and maybe together we can come up with a way to not use more than one for loops. Because I'm pretty sure functions and loops can do whatever it is you're trying to do. All right? Does that answer your questions yet?
Sir, my problem was I got two things running in the program. and it's doing one, then it's doing the other one. But I
And you
wanted
wanted
to
to
do both
two
at the
things
same
at the
time.
same time.
Yeah.
What are those two things? Right? What are those two things? I need context. Or maybe you can email me.
All right, so I'll do that.
You'll email me? All right.
Yeah.
Cool. So maybe you can look into doing a nested loop where while one operation is being done, another operation is being done. So you essentially just put one for loop inside of another for loop. So to have some bigger for loop, right? Some for something, and that's executing something else, executing step one or thing one, right? Then inside that, there's another for loop, right? Which is doing thing two, right? So it's like it does this and it does this at the same time. Okay. It's just that this one would be like slightly ahead, but it'll be doing two things at the same time. This is nested loops, and you can research that.
Okay, sir, I'll try it.
Good. Any other questions pertaining to the class exercise?
Sir, what did you say the serial begin 9600 do again?
So this essentially tells the Arduino we want to communicate with it via serial, so that, remember, your Arduino's out here. Right, let's call it AR. This is your Arduino. This is you on your computer. And that's connected via some USB cable, right? So that command, when we program it into the Arduino, when we say serial begin, it says, hey Arduino, while you're running your program, while you're running your code, right? Because Arduino is gonna want to run code, right? While you're doing that, just remember that I want to communicate with you via serial. So set up whatever it is you need to set up so that we can send messages back and forth, right? So essentially establish a communication channel, a serial communication channel, comms channel, right? And that channel, I want it to be defined as 9600 baud, B-A-U-D. What baud is, 9600, this is the baud rate. The baud rate essentially says how fast this communication is going to be. This communication is going to be 9600 bits per second, right? Or something like that. You can read into baud rate a little bit more, but essentially that's what it does. Because in order to communicate serially, right? Because remember, sending data signals, we need to know how fast those data signals are coming back and forth. So the Arduino needs to know how to compose its messages, right? Because serial communication is just one standard communication, but it can be at different baud rates, right? The default for USB, right, on computers is 9600. So that's why usually we use 9600, right? You can change it, but then you'd have to change other things as well, right? And I think there's a certain range that you can go to, right? But it's stuff you'll have to research on your own. And there are different ways depending on which operating system you're using, right? Good. Does that make sense?
Yes, sir. Thank you.
Good. So 9600 essentially says, send messages back to me. So in your IDE, right? Remember the Arduinos out there. In your IDE here, you're going to open it up on your computer, right? And you remember your Arduino is connected to one of these USB ports, right? And then you're going to open up serial monitor, and that serial monitor is going to open and you're going to see communications with your Arduino, right? You're going to see communications with your Arduino. So serial monitor here, and you're going to see those communications coming in on your screen. So it's like your Arduino sending you back the value that it reads from the sensor. So reading, analog read, the divot value, the voltage divider value at A5. It's going to read that value and then it's going to say serial print the reading. It's going to store that value in reading, of course, and it's going to be like, hey Neil, or hey Jarvis, hey Vlad, this is the reading I got. And it's going to send that over serial. So it's like it's communicating back to you, right? And of course, you can send things back. You can set up in your program to send things back to the Arduino. So from your computer, you can type like the letter L or the letter H, and the Arduino is going to pick that up because you guys establish a communication rate, right, of 9600. So it can pick things up. It knows how to collect back signals from you, right? So you can set up values like AJKL hello, or on, or off, or medium, or something like that, and send stuff back to your Arduino, and your Arduino is going to collect that back. Right? It's going to collect that and it's going to be like, okay, when medium comes into me via serial, then I need to run this part of my program, right? When off comes in via serial into this program, I need to run this, right? And you can have all sorts of different serial commands. So it's just a way of communicating back and forth with your Arduino board, right? Make sense?
Yeah.
Yes.
All right.
Yes.
Thanks.
So we start simulation, right? And you see that value comes in, right? If we comment the line off, start simulation, no value, right? No value, right? We clear it because this has a backlog, but no values coming in, right? No new values are coming in.
Okay.
Simulation,
Yeah.
put that back on, start simulation. Values, new values, different values, 800, 700, 929, right? What are these values? So you can put that in and it's very useful in troubleshooting your program, right? Knowing what's going wrong, right? Say for example, right? So here we just start simulation. It's continuously 28 because we're not changing this, right? We put in the middle, it's continuously 86 to 1. Let's stop simulation. Let's change this to A0. Let's say we typed up all this code, we fixed up our circuit, and then press start simulation, right? And the program is running weird. And we say, hey, why is this program running weird? Let me check troubleshoot via serial. Let me put in serial begin. Let me put in serial print line reading, and then come into serial monitor and look at what's being printed, right? And then we see, what are all these values? I'm not changing the circuit. This voltage here isn't changing, right? I'm not moving the slider. So why are these values fluctuating like that? Then you'd be like, is this program reading the right pin? And then you see V divot, then you go back up and you say, oh, A0, it's not A0, it's supposed to be A5. Then you click start simulation, and then you see non-fluctuating values coming in. So that way you know that this was the problem, right? So you can use it to fix your code as well. All right.
Okay, sir. So if we were to change the 9600 to a lower value, that would just change the rate at which the value is coming in, or is that a standard number
Yeah.
for?
So let me see. Serial to communication Windows 10. Let's see. It's just something I haven't researched, but I know the default usually for most things, most software, because again, you can have multiple software running, right? Running on a system. So one can be communicating at some bit rate and another can be communicating at another bit rate, right? Okay. Let's just check my built-in device manager in my Windows computer. Usually, like when you plug in an Arduino board, a COM, like a COM port pops up here. And from there, you can set baud rates and stuff like that. Or you can do it via your terminal, black and white. It's more of an IT thing than electrical engineering thing. But yeah, the baud rate default is 9600.
Okay, okay.
People do change it, but I don't know what the range is and anything else much about it. So just be wary if you're changing it, right? Okay.
Yes, sir.
So
Thanks.
so apparently you can like communicate with the Windows terminal as well. So you know CMD, you can use this as well to do baud communication. So not just your Arduino serial monitor, right? You can use this and communicate via baud. So in here, you're gonna be getting those same readings, right? By your terminal, right? Coming in. And maybe you can use some sort of programming language like C or Python or whatever to read from that rather than just reading from your Arduino terminal, right? To do something else, right? So you can use something like Python serial communication, right? Arduino, right? And you can set up a Python program to be running and the Python collect from a particular port, right? But they both pieces of the software need to know what communication speed you're at, right? They need to know how fast these signals are coming in, right? So you can set up Python, right? And you see here with Python, it says COM4. So COM4 is going to refer to like a particular USB port, right? And the baud rate, whatever you set the baud rate in your Python code is going to be the same baud rate that you're going to need to set in your Arduino code, right? So if your Arduino code, you put 9600, in your Python code to read from that, you're going to also need to put 9600, right? So just that like whichever software you're using, both of them need to be set up the same way. Yeah, but 9600 is a default that everyone uses, right? You know, like for your home router IP, people just do 192.168.1.1. That's just kind of like a default for residential consumer IPs. The same way, whenever we're setting up baud rates, everyone just types 9600 because that's just usually the default on most pieces of software. Yeah, but you can change it. You just need to know that if it doesn't work, maybe on your Arduino software, your Arduino ID, you might need to change it as well, right? Okay.
Yes, sir.
Yeah. It is useful though, like communicating via serially. So let's say you had some LED, like this LED here, and you had a web page, right? You had some web page open up, right? Some web page being hosted on the internet, and you wanted to log into that web page, right? And turn this Arduino light on and off. So what's gonna happen is on our web page, you're gonna press off, then it's gonna go to the server, and the server is gonna make some change in the system, right? let's say it's going to make some change in some text file, right? Some text file, new text file here. And it'll put a 0 in this text file, right? And you're going to have some Python program, some C program, some kind of program running in the background of your server, right? And that server is going to keep continuously checking this file, right? And the moment it sees that 0, it's gonna send a message to your Arduino serially, right? So that's going to be the same as opening this terminal and typing turn light off, right? But we don't want to be at the terminal in our IDE typing turn light off. We want the program to do it. So the program knows how to communicate with Arduino and it's going to send that turn light off message or whatever little code you got, 1, 2, 3, 4, 5, 6, 7, 8, whatever code you want to set up, is going to send that message to your Arduino. And your Arduino is going to be like, hey, this is the message to turn the light on based on the code I have loaded. And your Arduino is going to turn that light on. Okay, but your built-in Python program running on your server or your C program running on your server, your C++, your JavaScript program running on your server needs to have that same baud rate to communicate with your Arduino. Good, does that make sense? It does. I'll stop confusing you now. Right, but it's really useful and it's got to be creative with it. Right. So did anyone get through with the circuit? Is it working?
Is the LED supposed to be lighting up or not? Hi, sir, you there?
Yeah, go ahead.
Yeah, my LED is not lighting up, but the
Go on.
coding, it's saying it's correct. And there's no errors in coding.
Did you slide the thing?
Yeah, it's not going anywhere.
All
I
right,
mean,
share it. Share it. Let me see. Yeah, I think I need to enable share. Mhm. Okay. Your threshold value is 0, 0 in line 3. It's like 800.
the threshold value, so it's changed to 800.
If it's 0, 0. My code doesn't have 0, 0. Does it? Because that would be weird. Yeah, my code has 800. And the book's code has
I
500.
missed.
The book's code has 500. I put 800.
Sir, how we get in the sliding thing? That thing. 'Cause my code doesn't has that. My sir.
How do you get to what? Slide?
The sliding thing that Vlad has on his screen.
You click on the photoresistor and it's light.
I'm not really doing anything.
Just keep looking at it. Yeah, that's weird. Okay. Just comment off your entire void loop. So you know how to do like multi-line comments, just backslash. No, not the code inside the void loop, not the void loop. Like all the code inside the void loop.
Yeah, just
Comment off all. And just turn the LED on. I just turn the LED. Just type code to turn the LED on, like digital right. You know how digital right. LED pin high, right? Close bracket. Okay. So like, okay. Okay, good. So delete that line, uncomment everything, and let's look at the serial monitor. So at least we know that the line works, that the light works. So start it, let's look at the serial monitor. Okay. and the analog pin is receiving the values. Okay, good. So, all right, stop simulation. All right, minimize the serial monitor. Correct. So reading is that value. Okay. Bright is equal to 0. Great. Oh, your line 18, you remember we're using the map function, right? Bright is equal to the mapping. We're mapping reading to these values. So you need to put map open bracket. So if reading, no. So no, close, undo that. In the same line, in same line 18, all the way down to the end. Okay, I'm gonna share my screen again. You can go ahead and stop sharing your screen. Okay, so this right here, right? See here?
Oh, okay, okay.
Remember, we're using the map function to do that. To do mapping the values over, right? Because you remember, PWM is only from 0 to 255, but the analog read values comes in from anything from 0 to 1023. All right. To do that, tell me if it works.
Yeah, it's all good. Thanks. Yes, sir, it's all good.
Okay, good, it's working, right?
Yeah.
And there's some threshold somewhere in the middle here that just turns off, right? Which is what we want. Anyone else having issues? How it's supposed to work is it's supposed to be on when the place is dark, and as we slide, it starts to dim, right? It dims, and then somewhere along here it cuts off, right? Dim gets brighter, 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 and somewhere in the middle it cuts off completely. Right.
Sir,
Yep.
sir, I get in the sliding thing because I click in and nothing popping up.
So when you click, it doesn't
Alright.
pop up. Oh, do you click start simulation?
Oh,
Click start simulation, then click, and it'll pop up.
okay. Thank you, sir.
Okay, it works. Good. All right. Does anyone need help before we call it today? No. All right, good. So that's the end of class. See you guys next week. Next week, Monday, right? Okay, and good luck with finishing your assignments. Right? The due date, I think, is the 14th. So you guys know how to send me that. Just send me it by email. All right, so that's all I have for you guys. Enjoy the rest of your day.
Yes, likewise, sir. Thanks.